Natural Philosophy 3. Concepts we're missing. Are there important concepts we haven't yet arrived at that would help us understand ourselves better? In videos 1 and 2, I reviewed all the concepts we already have, representing them as a small set of counters, like this. So by scanning them, I could more easily judge where any important concepts most likely lay. In this video, I go one step further. I'm going to take each of the other counters in turn, one by one, and ask two questions. What do we already know about the impact of our discovery of the genome on what that counter stands for? And second, what concepts does that suggest we're still missing that could help us arrive at those concepts? Here we go. All right. Quantum particles and the genome. Here I draw a complete blank. I know nothing about quantum physics. There may be connections with genomes here, but if there are, you'll have to find someone else to point them out for you. Next counter. Physical matter and the genome. What we know. On the early Earth, heat from red-hot lava would make simple chemicals dissolved in water fuse into higher energy molecules. Among those molecules would be ribonucleic acid, or RNA. Unique to RNA, it can form threads that act as both code and as enzymes able to read that code to make more copies of itself. It can self-replicate. Self-replicating molecules of RNA, protected inside fatty bubbles composed of lipids, could just conceivably have been the first sign of life. These would have been just little bags of chemicals. They're not life as we know it, species able to evolve. The first sign we have of that is what we can deduce from species alive today about the very first species all other species evolved from. That species, able to evolve, how different was it from those little bags of chemicals? It was very, very different. It was immensely more complicated. And it could evolve, obviously, because it's the creature all other species of creatures evolved from. That's what we know. Now, concepts we're missing. Between those first threads of RNA and that first evolving living species lie all the secrets to how life originated. One secret was some of the RNA being replaced by DNA, a similar molecule but better for making genomes out of. What we're missing is what can turn little bags of chemicals into species of living creatures with genomes able to reproduce and evolve. That may be the most important of all missing concepts. That could be the key to understanding everything else about evolution, but we're not likely to discover it for a very long time. Now, natural intelligence and the genome. What we know. We've come across a number of indications of the genome seeming intelligent. Space. Identical twins with identical genomes are often so similar in appearance they're hard to tell apart. This shows us that although genomes come as linear threads, they can define complex shapes in 3 dimensions precisely. Coming as linear threads in 1 dimension seems to impose no limits on what a genome can achieve. Time. When a cell's DNA threads divide, this process is precisely orchestrated in fractions of a second. Development of an embryo proceeds in a predictable sequence measured in days or weeks. All members of any cohort of cicadas emerge at precisely either 13 or 17-year intervals. We see genomes intelligently managing time at every scale from microseconds to years. Number. One example, the tiny nematode worm C. elegans always ends up with exactly 959 cells, of which 302 are neurons. Genomes can count. Engineering. Genomes intelligently manage the most complicated imaginable process, the development of an embryo into an adult. Creativity. In the course of insect pupation, one kind of creature, a caterpillar, perfectly adapted to one way of life, transforms into a completely different kind of creature, perfectly adapted to an entirely different way of life, a butterfly. Coming up with such a transformation surely demonstrates remarkable creativity, far beyond anything we're capable of. Emotions. At puberty, we develop new feelings, prompting us to reproduce. For them to appear in us, they must have first appeared as code along our genome. Does this mean our genome has feelings? It does mean that our genome understands feelings and how to implant them in us. At least to that extent, we can say genomes have feelings. That's what we know. Individual ways genomes appear intelligent. What we're missing is how comprehensive, how wide-ranging must genome intelligence be to create and manage life? I think we've no idea. Rather than regarding a genome as strings of genes giving it a limited number of tricks, we may need to think of it as a supremely intelligent agent. To know that agent better, we surely need to learn a lot more about what evolution involves. Next counter, human minds and the genome. What we know, our brain is engineered for us by our genome. Growing it involves almost half the genome's 20,000 codes for proteins. At birth, our brain already has all the neurons we'll ever have, already connected to one another by 1 trillion connections, synapses. With age, we don't gain synapses, we lose them, ending up with only half as many. Every way we're different from a block of stone we get from having a brain. Everything we get from having a brain comes to us from our genome. If we have capacity for learning languages, or free will, or consciousness, we get it from our genome. What we're missing a lot more than 1 or 2 concepts. Our genomes must know 1 billion times more than we do about how our minds work. We'd probably learn more about how our minds work by studying our genome than by applying science to study our brain. Next is beauty and culture. What we know. We know we evolved to be capable of learning a language. We evolved fine hand-eye coordination. We become able to walk and run, to skip, to saunter. As children, we like to play, we like to perform for each other, to chant and sing. We like to gather in communities. We're social. At least some aspects of culture we know we get from having evolved. What we're missing: how many other talents do we come with evolved into us that we could draw on to enrich our culture that we've just not yet discovered? What a bounty that could be. How could we find them? Could we recognize them in what we learn about genomes? Do genomes play? Do they tell stories? Do they have culture? Wonderful possibilities here to explore. As for aesthetics, we know they can vary from one culture to the next. Classical Western taste favors symmetry, repeated objects evenly spaced, durable objects raised on plinths. Japanese aesthetics favors asymmetry, objects grouped as if by natural accident, the temporary and the fragile. In bonsai and ikebana, they already express an appreciation of ways genomes can manifest themselves. Can we develop an aesthetic celebrating genomes? I admit I've tried to, but each time I hit a wall. Perhaps as we discover more, such an aesthetic will emerge naturally. Another wonderful possibility. Morality and meaning. What we know. The ancient Stoics believed nature came organized by a universal reason or divine intelligence. Because it had embedded in each of us a small portion of its powers, it expected us to align our actions, thoughts, and emotions with its intentions. By undertaking this cosmic role, Stoics believed they could achieve enduring satisfaction. That's what humans used to know. Now, of course, we know what science tells us. There's no such thing as divine intelligence. Everything happens according to the laws of physics. We currently have no cosmic role. What we may be missing? Were we created specially to fulfill some grand plan? Our evolution involved amazing innovations. Our brains tripled in size. Walking on our hind limbs released our forelimbs for throwing and for fine handwork. Capacity to speak led to creating languages and writing. We used these gifts to create first agriculture, then cities, then science and technology. Does having evolved these amazing talents mean our genome has a mission in store for us? Could it be taking our genomes with us to other planets? Your guess is as good as mine, but it might be worth wondering why evolution has blessed us with such special talents. Perhaps we can learn from the Stoics. Their rational world spirit resembles what we've discovered about the genome and its role in nature. We might draw on their wisdom. Next counter, conscious experience and the genome. I'm skipping this for now. We know almost nothing about consciousness, let alone how it could be involved in evolution. I may tackle this later in a fourth video because it can consist of nothing but wild speculation, and I'd like to reserve that for its own video. So, final counter, the genome and the supernatural. What we know. Is the genome God or like a god? Not at all. We know the genome isn't infinite, it's earthbound. We know the genome isn't infinite, it's earthbound. It isn't eternal, it's no older than the earth. It didn't create the universe. It isn't infallible. Species keep going extinct. Genomes can't act as a personal god. They let most of their creatures serve as prey for the creatures of other genomes, so they can't care much for each of their creatures individually. So except for creating life, and perhaps being a lot smarter than we are, I can't think of any way genomes are like a god. What we're missing is meanings we used to get from having a god. Can we make the genome into a god? I'd rather we didn't. But I think the study of it could provide us with some of the consolations of religion. I think by studying it, we could find more meaning in being alive, even in being one particular evolved creature. I imagine in future, looking back from our deathbeds, we might start evaluating our lives in terms of how much we benefited from wisdom gained from the study of genomes. Acquiring this wisdom over a lifetime might become our new meaning in life. I've called this quest for missing concepts an exercise in natural philosophy. It required stepping out beyond the realm governed by science. But probably no other discovery has as much potential to change our lives as discovery of the genome. This is still at an extremely early stage. We're bound to live through a golden age of further discoveries. It isn't clear who will make these discoveries, since science is so insistent on denying intelligence in nature, except in us humans. Do we need some new discipline to bring forth these discoveries? Should we pursue them in the spirit of natural philosophy?